My name is Gaurav Singh, registration number 19BCE1835. This is the digital assignment 2 for the subject blockchain and cryptographic technologies, CSE1006. My topic is data digital signature algorithm, DSA. So coming to the introduction part. Uh, so let's say when a person sends a data through a document, so it becomes very important to identify his or her authenticity for the purpose of safety and security. So digital signatures are used for this identification, and authentication of the data means to be aware of who created them and they did not interfere during the transmission of the data. So these signatures are created using certain algorithms, and DSA is one of these algorithms. So what DSA is, it is a type of a public key encryption algorithm, and it is used to generate an electronic signature. So DSA is one of the many algorithms that are used to create digital signatures for digital transmission. So in DSA, a pair of numbers is created, and that is used as a digital signature. So these are generated using some specific algorithms. So what they do is they allow the receiver to authenticate the origin of the message. So the digital signature that is created using DSA is in private at the start pointing of the data transmission, uh, while it ends in public. So that means that only the person transmitting the data can make the signature, so which is to be added to the message. But anyone can authenticate the signature at the other end. So coming to the digital signatures. So the objective of digital signatures is to authenticate and verify the documents and the data. So this is necessary to avoid data tampering and digital modification or forgery that can happen during the transmission of the official documents. So with one exception, they work on the public key cryptographic architecture. So typically an asymmetric key system encrypts using public key and decrypts using a private key. So for digital signature, however, so the reverse is true. So the signature is encrypted using the private key and it is decrypted using a public key. So because the keys are linked, decoding it with a public key verifies that the proper private key was used to sign the document, and then thereby verifying the signature's provenance. So coming to the diagram, I'll explain this. So here the capital M signifies the plain text. Capital H is the hash function. The small h is hash digest. The plus that bundle both plain text and digest. The capital E is encryption. The capital D is for decryption. So what this diagram shows is the entire process from signing of the key to its verification. So I'll go to the step-by-step process. So firstly, M, the original message, is passed to a hash function that it is denoted by H hash to create a digest. Next, it bundles the message together with a hash digest H, and it encrypts it using a sender's private key. So then it sends the encrypted bundle to the receiver, who can decrypt it using the sender's public key. So once it decrypts the message, it is passed to the same hash function H hash to generate a similar digest. Then once it decrypts the message, it is passed to the same hash function H hash to generate a similar digest. So what happens is that it compares the newly generated hash with a bundled hash value that was received along with the message. So if the match, that verifies the data integrity. So there are so what these others are industry standard ways of implementing the above methodology. Those two are RSA algorithm and DSA algorithm. So both the algorithms serve the same purpose, but the encryption and decryption functions differ quite a bit. So now I'll explain the uh, DSA algorithm. in depth. So what it is a Federal Information Processing Standard (FIPS) for digital signatures. So first it was proposed in 1991 and it was accepted globally in 1994 by the National Institute of Standards and Technology. So it functions on the framework of model explanation and discrete logarithmic problems, which are difficult to compute as a forced brute system. Uh, so it provides three benefits, which are I explain. So first is message authentication, integrity verification, and round reputation. So message authentication. So we can verify the origin of the sender using the right key combination. Integrity verification. So it is not possible to tamper the message since it will prevent the bundle from being decrypted together. Non-reputation. So the sender cannot claim that they never sent the message if verifies the signature. Now I'll explain the diagram. So now I'll explain the image about the entire process of the DSR algorithm. So we will use two different functions here, a signing function and a verification function. So the difference between the image of a typical digital signature verification process and the one that is being displayed is the encryption and the decryption part. They have distinct parameters, which I'll explain in the steps section. So coming to the steps. So, keeping the image that was shown just now in mind, so how we now see how the entire process works, starting from creating the key pair to verifying the signature at the end. So the first thing is key generation. So what we do is first we choose a prime number, let's say Q, which is known as the prime divisor. So another prime number P is chosen such that P minus 1 mod Q is 0. So now we choose a integer G such that it is less than P but greater than 1, satisfying the two conditions G uh, Q mod P is equals to 1 and G is H whole multiplied by P minus 1 divided by Q mod P. A formula, it satisfies a formula. So X is a private key and it is a random integer such that X is greater than 0 but less than Q. Y is also our sorry, X was the private key, Y is our public key, and we can calculate Y as GX mod P. So the private key package is PGQX and the public key package is PQGY. The second part is signature generation. So it passes the original message M through the hash function H hash to get our hash digest. So it passes the digest as input to a signing function whose purpose is to give two variables as output, S and R. So to calculate the value of R, we use the formula GK mod P mod Q. And to calculate the value of S, we use the formula K minus 1 H plus X R mod Q. So that calculates the entire signature packages as RS and the entire bundle of the message and signature MRS are sent to the receiver. Now coming to the third part, that is the signature verification. So we can use both the hash functions H hash to generate the digest hash, the same hash function. So we can then pass the digest off to the verification function, which needs other variables and parameters too. Now we can compute the value of W as SW mod Q is 1. And we can compute the value of U1 with the formula U1 is equal to SW mod Q. We can compute the value of U2 with the formula U2 is equal to RW mod Q. And we can also compute the final verification component, which is calculated with the formula. So then we compare the value of V to the value of R received to the bundle. If both matches, the signature verification is complete. Now coming to the importance of the digital signatures. So all cryptographic analysis of the digital signature using the public key cryptography is considered very important or main and useful tool to achieve the information security in both cryptography and crypto analysis. So the apart from the ability to provide non-repetition of the message, the digital signature also provides the message authentication and data integrity in cryptography. So due to the ever increasing cyber threats, so whenever user sends the data over the internet, it is very necessary to identify and verify the owner's authenticity. We must ensure that the document owner is credible and no one has made the changes during transmission. So digital signatures are used here. So the benefits of using DSA. So first is message authentication, data integrity, and non-repetition. So coming to message authentication. So when the verifier validates the digital signature using a public key of a sender, she is assured that the signature has been created only by a sender who possesses a corresponding secret private key and no one else does by this algorithm. Data integrity. So if in a case like an attacker has access to the data and modifies it, so the digital signature verification uh, at the receiver end fails in this algorithm. If such a case happens, so what happens now is the hash of the modified data and the output provided by the verification algorithm will not match, of course, the signature by this algorithm. So the now the receiver can safely deny the message, assuming that the data integrity has been tampered. Non-reputation. It is just a number that only the signer knows as a signature key. So he can create a unique signature of the given data uh, of that message to change in cryptography. So thus the receiver can present the data and the register signature to a third party as evidence if any dispute rises in future about related to the security of the data. Coming to the advantages. So first, it is highly robust. It is speedless storage. It is pattern free. DSA is highly robust in security and stability aspect as compared to alternative signature verification algorithms. It has better speed. It is much faster compared to the uh, rival RSA algorithm and as such. So it requires very less storage to work in its entire cycle. When NISC released it, it was partner free, uh, so that people around the globe can use it free of cost. So along with having strong strength levels, the signature's length is smaller compared to other digital signature standards. Coming to the disadvantages, so it requires a lot of time to authenticate as the verification process includes complicated remainder operations. It requires a lot of time in computation, in short. So data in DSA is not encrypted. We can only authenticate the data. So the digital signature algorithm firstly computes with SHA-1 hash and signs it. So any drawbacks in cryptographic security of SHA-1 are reflected in DSA because DSA is simply dependent on it. So coming to the part DSA and RSA, the differences in them. So DSA is an asymmetric key encryption, as I said, but it was adopted by the USA agencies for secret and non-secret communication. RSA, on the other hand, is a public key cryptography algorithm that uses a modular arithmetic. So its strength relies on the problem of a prime number factorization to secure the communication and digital signatures. So hence, unlike other usual encryption algorithms like RSA, DSA is standard for digital signatures. Even though both incorporate different mathematical algorithms, the cryptography strength is equivalent. The main difference of the two algorithms comes down to speed, performance, and SSH protocol support. So in contrast to DSA, RSA is slow in decryption, key generation, and verification, but it is faster in encryption and signing. So, however, authentication requires both, and speed discrepancies are insignificant in real-world applications. So another difference lies in the support for secured shell network protocol. So RSA supports only the original SSH and its second version SSH2, while DSA only works for SSH2. Coming to the conclusion. So it is now clear that the digital signature is one of the best authentication tools for electronic records. So on account of its cost, security, time, and speed, the digital signatures are popular nowadays. So in today's interconnected and digital world, so digital signature algorithm is very vital for creating a safer and secure environment. Thank you.